6 interesting flash talks. We were going through the list, and we curated a few uh, to spice up a faster discussion and to ignite some thought. To start off, are we set? To start off, we have Harsh, who is going to get into a little bit of generics in Go. These are all 5-minute talks, and if you all want to see some entertainment, these are flash talks. So they are exactly at 5 minutes. So in case one of the speakers takes more than 5 minutes, you will see me come on stage and tackle that person off the stage, which is why I'm also called Tackleya. All right, first up, Harsh.
Hey, hi guys. So a quick show of hands who here in this room have already used generics. Okay, I think 50% of the room. Who here has used generics in a way like you can, which were introduced in the latest version of Go, like using them in composable functions, using them with databases, handling null values? Okay, so here I am for you guys. So my name is Harsh. I'm working as a senior associate blockchain at NPCI. So today we'll be talking about some basic concepts of generics as well as what have been introduced in the newer versions. So for those people who are not aware till now, so generics were introduced in 1.18 version of Golang. These allows functions and data structures to work with different types safely. When we say safely, what that means is in real time, idealistically what happens is as soon as you run your code, then you are determining whether that interface which you have accepted as a parameter, which was empty, that we are trying to convert it into a string, int, whether it will work or not. We are handling the situations over there for panics, for error cases. That's all sorted out with generics. You can do that at compile time only. So if you can see the example on your screen, there's a stack, a simple stack implementation which are push and pop functions. There are two implementations below. One, the stack is initialized with an integer data type. And you can see as soon as we try to put a string into that, it is not working. Why? Because it has been initialized in such a way. But in the second example, if you are initializing it with any, which is an empty interface, you are able to use the same push and pop functions with integers, floats, as well as for strings. So this is generics for you. Now, there are a lot of things which needs to be considered. So performance considerations. So generics, as I mentioned, is already initialized, instantiated at compile time. So at runtime, you are not worrying about your code getting compiled or getting panics because your code has already taken care of what kind of inputs are coming in. Second, let's say there is a code and there is a function which is supposed to accept 3 or 4 kinds of different data types. What you are doing is you are putting conditions, switch cases to typecast it and handle all these scenarios, and assume there are like 10 functions like this. So the code size has been increasing drastically. You won't even know when your binary size has been increased. So generics are also helpful in that sense. While using generics, the third point is a very important point. You have to benchmark your hot paths. A code which is extensively being used, which is either, let's say, a read-heavy function or a write-heavy function, you know that this function is going to be constantly used by your users or by your whoever your customer is. You need to benchmark it properly because you won't know how generics is going to behave in such scenarios. The legacy systems and the legacy code is already there, which has already been tested. But you have to use generics also, you can test it out. And how to use them with composable functions. There are also a few things which for you guys to explore, and you guys can also put your thought into this. So first, there are some efficient libraries who have already been using generics, and they have introduced their libraries. People are using them, using generics. So it's for you to all explore, add them in your code, and try it out. Also, there are a few things which have been introduced in the latest version of generics, which we'll be talking about. Yeah. So in the latest version, which is 1.24 of Go, going ahead, there is a built-in min and max function. We all have faced this. We already tried to write a min function, max function with the constraints over that particular type of data type. That has been solved in this generics. Also, there is a really fine-grained error messaging which has now been given. Earlier, it was not that much good. Now you can have a very good error messaging so that you can understand what you are trying to explain, why your code broke. Third thing is generating a random number, how to generate that. And the fourth and the most important thing, which we will also see the code base for, This generics has also given us a chance to handle nullable values in our databases. I hope everyone in this room have faced these issues that sometimes while creating a, let's say you are trying to create an SQL table, you are trying to do something. As soon as you do that, you find that, okay, this is a nullable field. As soon as you are trying to read that data, it is failing for you. Here you can see, this is the problem. Either you have to, there are 4 different types of data types, and either you are handling these things manually, you have the problems of null string, null ints. This is causing issues. How generics solve this is, this particular data structure you can see in line number 18, you have to define them multiple. So I'm just taking 10 more seconds. Yeah. So how generics solve them is, either you just have to define a single interface. Now this interface can accept different kind of data types depending on what kind of functions you have implemented. So, and this is a generic function, which is go, get, or default. This is the same function which can be used for all the things for handling SQL queries. So I'll wrap it up for the time being. Thank you so much.
Woo! Just missed. All right. Our next speaker is Sushmita, and she's going to be talking about Go traces.
Okay. Hello, everyone. My name is Sushmita. I'm working with George Softwares, and I have been working in Golang since 8 years now. I have developed like kind of web application from fintech to e-commerce, all using Go. So I have here some experience to share. I want to share with you the Go traces with flight recorders. These are advanced performance debugging tools in Golang. Now let's start with the basics. First is pprof. We all know that's profiling. So Go provides you 2 types of profiling, that is CPU profiling and memory profiling. The CPU profiling will give you the system calls, the CPU execution times, while the memory profile will give you the memory leaks and insights into the garbage collector, like when your objects were allocated and deallocated. So it's a basic tool, right? We all have been using this tool. So how do we analyze the output of this tool? We have pprof tool, where we can analyze using text formats, where you can see the calls, system calls, and how many seconds or milliseconds each system call is taking. We have some web formats, where we generate the graphs, and all the edges represents how many system calls were made, how many times it was made, and how much time it got. We also have GoTorch, that is a flame graph that you generate using GoTorch tool. So this is a flame graph, and you can see it has many colors, right? So each color represents one layer, and the darker the shade is, the more you can say like execution time or memory is taken by that process. Now these are all basic tools which Golang provides. Now since Go 1.22, we have Go traces. So many of you must have not used Go traces because it is not that popular in the community. So let's see what traces actually do. So traces are very different from profiling. It will give you insights into how many Go routines are running, how many channels are present, and what is blocking this channel or what is blocking this Go routine. So there are different ways you can generate the traces. One is using your testing package. You can use the trace flag with your go test command. All the output of this trace will be saved into trace.out. The trace.out file is same as prof file. You can analyze web graphs to see the insights into this. If you have a standalone application, you can use trace.start and trace.stop. Now, what are the limitations of this? Why still Go trace is not so popular? Because we have 3 versions, right? Now we have Go 1.25. It is because of overhead. We are continuously writing the traces, and it's very hard to use in production. Now, there comes Go 1.25. So have you faced a problem where your API is very, very slow in production, but you can't use profiling on it because the event has already occurred and after that, you're doing the traces. So to fight this problem, we have flight recorders. So what is flight recorder? Flight recorder will record the traces for you in your production environments with your APIs. Let's see how do we implement this. This is the code snippet. Let's dive into it. Now, if you see line number 1, we are creating a new object of the new flight recorder, and we are starting the recorder. Then we have a handler function. It could be any handler like login, logout, etc. Into your handler function, you just have to write one condition. That is, if your API is taking more time than 300 milliseconds, just grab a snapshot. Okay, this snapshot will be used for, you can use this snapshot to trace out all the memory allocations, the Go routines, the block channels that you have been using in your code. Thank you. So if you use the flight recorder in your code, please do use it and share your experiences. Thank you.
You know, they always say the essence of a great speaker is when you are spot on time. And the essence of an even greater host is when you get to tackle somebody off stage. So next up, we have Shashank. And he will be talking about a different way of looking into and implementing concurrency.
Hi, everyone. Today, I'm here to talk about a different way of thinking about concurrency in Go. Go has made spinning up Go routines very easier, but it comes with its own issue. Like if you are managing shared states, it is very difficult to implement that. Now let's see how actor models come to rescue. In actor model, the state is always bind to a single Go routine. So there is no shared states. And if you want to update the state, you have to pass it through a message. So here, since there is no multiple Go routines racing for the same states, it is always easier to scale. If we don't even need to consider whether the Go routines are in the same system or across the cluster. It will be easy to scale across the cluster itself. And Go has very good tools native to facilitate this actor model. Here, Go routines will act as our actor, which will hold the state, and the channels will be our messaging boxes, where we can send message to an actor via the channel, and based on the select, we can perform different operations on the state. Here is a simple example where we can see we are spinning up a single Go routine, and to make the action performed by that actor, we are sending it a message saying that just print, hey, and now let's dive into a quick real-world example. The previous example was pretty simple one. Here is a better example where we are designing a multiplayer game. We can have a player getting attacked from different angles. To avoid, to build that system, we'll be creating a player struct which will be having a health points. And to protect the race conditions, we will be using mutex losses whenever we are doing actions on that health. Here is a simple benchmarking snippet I have given. Now let's see how actor models is different. In actor model, we don't make the state bind to that struct. Instead of, we will be binding that state with the Go routine. So here is the player Go routine, where he is having the health. And to update this health, we will be sending messages through this channel. And based on whether it's a damage type, we will be decreasing the health. Here is, now let's see, the code looks pretty easy and easy to understand and cleaner when we comparing to mutex. There may be conditions where this is a simple code, so we understood where to lock and unlock. But if the code base scales, we would be, there is a chance that we might miss this unlocking, or there may be a starvation. So if we perform the benchmarking here, we can see that the actor model is performing more operations at the same time and taking lesser space allocations, which will be useful when we are considering about garbage collection. It does not need to frequently clean up the spaces. More examples where we can use this actor model is when we are implementing a chat server. We can have a actor bind to a user per session. Whenever a user comes up, we'll be spinning up an actor to binding that user. And he will be just receiving messages. And whenever a user logs out or he is disconnected, that actor will be moved out of the memory. So it is easier to scale, and it is predictable scaling, where if we just spin up Go routines, we might not be able to know whether the CPU might be starving, or we might just spin up multiple Go routines which are competing with each other. This is a different way of thinking of Go routines. And next time when we are thinking about designing a concurrent systems, think of actors instead of just spinning up Go routines. That's my take. Thank you.
A little bit of theatrics goes a long way. Spot on time. Our next speaker is Yash, and he just told me that he's getting married recently. And I said, dude, only crazy people get married. And he is going to talk about even a crazier concept. How he wants, because he's in this zone of marriage, he wants to see how Go and Rust can get married. Give him a tough time.
Hello, everyone. So a lesson for everyone is never share any personal data with Gotham. So yeah, anyway, so since we are only have 5 minutes, so I'll just tell you a very interesting story. So I work at Flanksource. We're building like a internal developer portal. And on a normal Tuesday afternoon, one day, I just get an error that some pods are giving out of memory errors, which means that they're taking much more memory than they're allowed to. And then what happens is that they are in a restart loop. So then that's pretty weird. And then when we went further into what's happening, we actually realized that it's just happening for one client, which is weird because we have a single tenant architecture. So each organization gets their own database. So there was not really a bug in the code that could do it, because then if there was a bug, everyone would be facing this issue. So then after a lot of head scratching, we saw memory graphs, and then memory graphs didn't really help at all. Because in case of a memory leak, the memory graph just goes up and up, up and up, and then it just goes down, and then it restarts. So how else to debug? So Sushmita gave us some really interesting ways, which is you can use profiling. So we profile the code, and then so the culprit was, if you could see on the screen, there's a Myers shortest edit sequence that's taking 96% of the memory. What was actually happening is we keep a change log of all the diffs and changes that happen in your infrastructure. So it looks something like this. So yeah, this is the diff. And this function was giving out of memory errors. That's pretty weird. And why is that happening? On like further deep dive, I saw that there were certain entities that were more than 1 MB in sizes. And when you have thousands of those entities and you're processing them in a like very short interval, yeah, you can overload the Go. You can overload the library and it can crash. So what to actually do now? So we thought of alternatives. So there were like 3 possible alternatives we thought of. One was that you create a buffer and then you only process what you can. Not ideal because since it's also used for incident response. So if you're getting a change diff much later because we are slowing down the processing, that's a bad experience. Then another way was that you create a new pod and then you handle the big resources separately. Not ideal as well. And then last was to playing around with the garbage collector, because like the way Go works is it has a garbage collector, and you can tune it, you can tweak it, and it can like kick in when it decides. You can also play with the garbage collector settings. So there's something called Go Mem Limit and Go GC. How that works is you can define that when your heap hits a particular memory size, garbage collector should invoke automatically. But the problem is when the garbage collector runs, it kind of slows down your app. So that was also not ideal. We tried with a lot of settings, and we could not find a sweet spot. So one day, it just popped out to me that, so the problem is really with the way Go is designed. Whilst it's a statically typed language, which is good, it has a garbage collector because I don't manage the memory, someone else does. What if I use something that automatically manages the memory? And then I came to Rust because, yeah, like if you know, Rust is incredibly hard to learn. And one of the reasons is because you, as a developer, have to keep count of where the memory is and where your references are. But I still figured, why not try an experiment? So yeah, so there is something called FFI, which is foreign function interfaces. And the way it works is that Rust gives you FFI for C. And then yesterday, Alex told us in a very interesting way how you can use the C functions and call them from Go. So yeah, so if you could see, I'm calling c.print string. And below, this is the Rust implementation for that. And it somehow compiled, and it worked. I won't be going into a deep dive. You can like see my blog. But eventually, the result was this. So I did like a Go bench test. That's just the result. And yeah, yeah. So yeah, the result was that in Go, the memory allocated was 4 GB. And, and in Rust, it was 350. So yeah. And as you can see, the allocs are also less. So if you are in this kind of a pickle, it's always better to try Rust in these scenarios.
Dude, you're going to get deallocated.
It's also Gautam's favorite language. He won't admit it to you, but yeah, he writes Rust in secret.
Finally, I got a chance to do that on stage. Now I just have to figure out how I have to edit that recording. All right. Thank you, Yash. All okay? So our next speaker is Anupam. And Yash is going to get married. Anupam got married. Oh, sorry, it's Akshat. Akshat, you just got married? All right. Hang on. थोड़ा वो tackle करके ना. All right, think test, and then we'll move into the married phase. Akshit.
Thank you, Gautam. Hello, everyone. I'm Akshit from NPCI. So I'll be talking about sync test package. So what is sync test package? So we use this package to test concurrent code. It's an experimental feature in 1.24, but a full-fledged feature in 1.25. It's a simple package, just two methods, test and wait. But why do we need this package and what are its limitations? We'll see with a use of code actually. So this is a simple code. We have an execute method and it spins up a Go routine, and for every tick it receives, it will execute a work function. So the basic test case for this type of function would be something like this, and believe me, this test case produces undeterministic results, okay? Sometimes this passes and sometimes it fails. So the other better way to implement a test case for this kind of thing is to use fake objects. So, but for to use fake objects, we need to modify our code a little bit. So we'll be using a ticker interface, our own ticker interface, and we'll be implementing the ticker interface and a fake ticker object here in our test cases. So by using this fake ticker object, we will be controlling the number of ticks we send to the execute method, okay? So this produces deterministic results. Either it fails completely or it success completely. No pass and fail, something like that. So, but if you observe it, our code got complicated. For a simple execute function, we declared an interface, implemented a fake object, and it got messy and unreadable and complex. So now, if we try to use a sync test for this test case, we'll see what kind of results it produces, okay? So you don't need to change your already existing method, okay? We'll be using execute method. Our test method will be passing as an argument to sync test.test method. It's an argument. The interesting thing about this test method is that it creates its own bubble environment. And in that bubble environment, it has its own logical clock, so which is completely different from your machine clock. And this logical clock moves forward only when all the go routines in your .test method are blocked. This is an important rule to remember, actually. So if you observe the code, I passed my method inside the syntax.test. I'm trying to call the execute method. So for every 1 millisecond, I will be incrementing the atomic counter by 1, okay? So I mean, coming to the flow, in this execute method spins up a go routine and it will be waiting for the tick to receive, okay? So one go routine is blocked here. It is waiting for the tick. The .test, this itself is a main routine here. So when we sleep at this line, the sleep in the bubble environment is considered as a blocker, okay? So now your main routine is also blocked now. So all the go routines, 2 go routines are blocked in your bubble environment. Now your logical clocks moves forward by 1 millisecond. So the counter got increased by 1, your sleep got decreased by 1 millisecond, okay? And now again, your go routine in your execute method is waiting for the tick and your sleep is still there. So again, everything is blocked. Your logical clock moves forward by 1 millisecond. So the counter is incremented to 2 and your sleep got reduced by 2 milliseconds. So this happens for 999, okay? At the 1000th millisecond, your atomic counter got increased as well as your sleep is done. So immediately after sleep is done, the wait method is being called. So what's the use of this wait method? It will stop your test execution. It will not cancel the go routines, just stop the execution, okay? So that we can get the value or whatever counter value we have from that go routine without causing any data races. So whenever you want to fetch a value, use synctest.wait, okay? And you load and you compare. And this also produces a deterministic kind of results, okay? This also produces deterministic results, okay? So, but it has its own limitation actually. Whenever we have a complex time functionality, these are just 2 things. But if you add one more time delay inside this work function you have, this fails completely, okay? These are its limitations. Please explore the package and use it to find more limitations. Thank you, and that's my time.
Don't worry.
That's called stage presence. Okay. So, are you sure? Did you talk to your wife? Okay. So, Anupam has spoken to his wife and he can give a talk here because it's a controversial topic though. Hot patching. वो क्या प्रोडक्शन में गया है ना शादी अभी तो अभी हॉट पैचिंग करना पड़ेगा आ जाओ सर
Hello, everyone. I hope the slides are visible. Yeah. Okay. So, quick show of hands. How many have you redeployed your service in the cluster after you found out that there is a bug or something? And you want to introduce a new feature in it. So I think you have to redeploy that service, right? So what do you face? You face a downtime. So which leads to a bad reputation in the users, and they face, and it creates a bad user interaction, right? So we'll be talking how to replace it. We can dynamically reload the service and upgrade it to the version 2. So this problem can be solved by atomic pointers. So how it works is, we have an atomic pointer, and in handler states, we have 2 states, the reader and the writer states. So the atomic pointers, when we want to store a new value, it directly replaces the store value, that is the data word of the pointers. And the ongoing request, which is in the clusters, that go through the load states. So it sees the old handler. So there is no blocking of the ongoing requests. So we can seamlessly replace the new service with the old service. So yeah, how this works. So we want to reload a SO file in it. So this will, we will look for the handler pointer and replace with the atomic store. So this never blocks the ongoing requests. So what happens is in the current situation, when you want to deploy the new service, that is the loading the new SO file, it goes through the in-flight counter. So when the in-flight counter sets to 0, that is the ongoing request gets 0, then only it reloads the entirely. So there is the in-flight request also goes on, and the new request is the new handler. So there is no blocking of the current request. So we'll see how it deals with the high RPS systems. So you can see like there is a live code swap, and you will see that there is no downtime in it, and we get a stable QPS as well. So hot patching does not increase the TPS, it is just swapping of the service. That's it. We'll have a quick demo of it. So let's assume we currently have only one feature, that is add, in our system. And we have defined an admin endpoint which will be responsible for reloading the new versions. Like we can set up an endpoint that will be responsible for the upgradation of the services. And we have defined the current handler as the atomic value pointers. So let's have a quick go through. We're starting out the server here, and we'll be never closing it. And we'll try to have a curl through this. So we can see that we currently have only one endpoint available in our service, that is add. And if we try that endpoint, it is actually working. But what if we want to try out a new feature? So we had only add. Now we are trying out the subtract. The screen is visible, right? Yeah. OK. Oops. This is not working. The feature is not available. So we have defined a version 2 of our service. So here we will be keeping all our endpoints, add, subtract, multiply, delete, anything. So now we'll be upgrading through it. So what are the steps? We have to build out the SO file of our new version of the service and load that library in the current service. So yeah, we have already, and we have to hit the admin endpoint. So whatever endpoint is responsible for loading that service, we have to just tap that endpoint. And we can see that our server has never stopped. And we have hot patched the server. So now we can try out the existing add, that is also working. And subtract, that is also working. So we have seamlessly upgraded our service without any downtime. So yeah. So just a quick recap. This is actually responsible for upgrading a small configuration changes or a lightweight services and all. But for the bulkier systems and data structures, we should actually combine it with the immutable snapshots and the sharded logs to avoid the contentions. So yeah. Thank you, everyone. The repository is available in that GitHub, and you can connect me for any further questions. Thank you.
the flash talk, I would like to do a small announcement. People having their names listed on that board under the serial of 15 to 20, please report to the backstage. We will get the laptop setup done. And let's start with our first flash talk of the day, Chakshu Jain. Stage is all yours.
Hello, welcome everyone. I am Chakshu Jain, Senior Associate Blockchain Engineer at NPCI. And this is my flash talk, Go Maps Revolution with Swiss tables. The recent improvement in the Go Maps using Swiss tables is no less than a revolution. Today, I will be talking about Go Maps implementation using old and new approach. In Go 1.23, maps are implemented using buckets of size 8. When you have to insert a new key, you take hash of it using a hash function and determines which bucket it belongs to. Then you sequentially probe all the slots, and if the bucket is full, you create another bucket called overflow bucket and links it to the original bucket using pointers. The problem with this approach is that overflow buckets get memory allocation far from their original keys, and this leads to CPU cache inefficiencies and slower lookups and insertions. So now let's see how Go 1.24 approach using switch tables addresses this problem. Switch tables are a form of open addressing. In Go 1.24, maps are a directory of multiple switch tables. In a switch table, there is a single backing array of size 1024, which is divided into logical groups of size 8. There is also a metadata array called control word, which tells the state of the corresponding slot of the group, whether it is empty, deleted, or in use. Now, when you have to insert a key, you take hash of it using a hash function and determines which group it belongs to. Then instead of checking sequentially, you parallelly probe all the slots using SIMD instructions supported by SIMD hardwares. And if the group is full, you probe into the next group. So these two improvements, parallel comparison and implementation without chaining, makes this approach highly cache-friendly and significantly faster. Now let's see some real-world impact. So in micro benchmarking, maps operations are up to 60% faster. Also, there is a Datadogs case study where they did some rigorous benchmarking on a large map having entries around 3.5 million and observed an impressive 70% memory reduction. So what's next for the Go maps? So there are more improvements in the pipeline. Few of them are extending the SIMD support to more architectures. Currently, Go 1.24 support AMD 64. Also, group size can be increased to 16 slots, which means 16 parallel comparisons, and therefore less average number of probing. And then there are some research around elastic hashing, which also could contribute to the further improvement in the maps. Thank you.
Great. So we all had one rule, no claps or all claps. Can we hear the great round of applause for our first speaker? And the next speaker we have is Gaurav. So let me talk about the topic. His topic is Whisk, basically a project which he built out of desperation for Whisk.io. Let's hear more about it. Over to you, Gaurav.
Okay, let me know if you guys can see things a little clearly. Not that good, actually, I see. All right, I'll zoom a little more, so it's a little readable. Should be good now. All right, so this talk is about a desperate move that I did while I was trying to submit a talk for Wasm.io. For those who don't know, it's a conference that happens in Europe every year, and this is my attempt to make to that conference. So who am I? My name is Gaurav. I'm a staff software engineer at Acquia. I'm also an open source contributor to multiple projects, Akri, Tinkerbell, gRPC Go, Flalco Sidekick, and Fission, just to name a few. Why I did it, I already told you this was a desperation move to make it to Wasm.io. Unfortunately, it didn't happen. My talk was not selected. But I learned a lot in this journey, and that's what I was to share here. The goal was to execute a simple what program. What is what? It's a WebAssembly as text representation. And it looks something like this. So at the top, you see a what representation. This is a basic function that you see. I'm exporting a function called run, which takes nothing as a parameter and simply returns a 2 as a number as an output. And below, at the bottom, you see a hexadecimal representation, which is a Wasm module. Let's take a closer look at it. So there are multiple portions, as you can see. There is typed specification that is part of the Wasm module. At the top, there is a signature that is used to identify whether it's a Wasm module or not. And then each module is divided into multiple sections. There is type section, function, code section, and all those stuff. Unfortunately, I can't go into details, which I would love to, but feel free to connect with me at a later point. Now that is done. All right, so this is a function body. What it looks like is in a hexadecimal representation. All this is available in the code repository that I have and will be sharing later soon. So what is Whisk? Whisk is the name of the project that I have built. It was built in 5 days using Rust, and this is my bare bones attempt at writing a runtime from scratch. The project I'll be demoing just now is WASP. It's a WebAssembly-based pipeline, just a simple name. The tools I've used are what to Wasm, which is I've used a program to compile into WebAssembly modules. I use TinyGo. There was a talk earlier about WebAssembly. It talked about the web browser aspect of it in terms of WebAssembly. TinyGo is required when you want to use WebAssembly written in Go outside the browser. The standard Go modules do not work at all outside the browser. Then I also use Rust C because I have simple modules. Otherwise, I could have used Cargo as well to compile my code in Rust to Wasm modules. So before I go, thank you. This is bad. Let's do a quick demo. Even before that. So these are 4 modules that I will be using. On to the left, top left is a what representation of an init function. On to the right is a simple function that adds 2 numbers. The third, on the bottom left, is one written in Rust. It takes in a number and does a simple cube, and the last one does a print. So let's do a quick run. Okay, we are already here. So this has some make operations that are available for you by default. So if you run make, you have these things available for you. You can build the Wasm modules just by typing make modules, and it will combine the what, go, and the Rust code that you have just seen into the Wasm modules. Once done, you can clear the screen for good, and you simply say make run. And what happens is, what you just see is a polyglot pipeline that was run or made possible because of WebAssembly outside the browser. That's the primary thing that I wanted to highlight on. I can quickly show you the pipeline itself. This is how the pipeline looks. I'm just saying this is the name of the pipeline. The runtime using is Whisk. You can also use it with Wasm Edge, or Wasmer is also another option that you can use. Otherwise, the rest is very simple. This is the name I wanted to give to the task, the module I wanted to run, and the language just for the show purpose as to which language is associated with that particular module. And yeah, that's primarily it I wanted to talk about. And here are the ways you can connect with me. Everything is available onto, oh, it's not visible there. Awesome, no worries. Can you see, okay, you can't? There you go. Now you can see it. You can scan it. Feel free to connect with me. Everything is available on GitHub. Thank you. And I'll just take another second to move out. Yep.
Thank you, Gaurav. So all of us have heard a lot about AI in this conference. So let's have a bit more gist about agentic AI. Our next speaker is Abhishek Jain from Josh Software, speaking about how agentic AI can be a magical tool for your system. Over to you, Abhishek.
Thank you. Thank you so much, Sonal. Hello, everyone. My name is Abhishek Dhundalkar, and I'm working as a software engineer in a Joe Software. So we have heard a lot about agentic AI and AI tools and the revolution and how we have to adopt all the such agentic AI tools in upcoming future, right? So here, putting that thought in front of us, so I'll be walking you through agentic AI topic. So let's see. So as we have a lot of discussion around it, so basically, what is agentic AI? So at the end is nothing but an AI system that can autonomously taking certain decisions, and based on that particular decisions, it's trying to act on behalf of LLMs and on behalf of that tools. And they have certain goals to perform, and based on that particular goals, with the help of their task, they are just performing certain actions for us. And why agentic AI? So we all know agentic AI is getting a lot of boom in the future. So here are some figures that I have noted for you. So there are 87% of businesses are running manually, and they need automation to revolve, to make a robust application around it. And around 60% of work can be automated as of now. And these are the real statistics that I have collected from the news. And with the help of agentic AI, we can make 5x faster task completion of any particular task. So when we are talking about agentic AI, so there is term called agent. So under the hood, the LLMs are nothing but are the agents. They are working on behalf of the system. And on the screen, here we have some core components while we are talking about agents. So the first one is role. As I've earlier said, role are nothing but the function that is given to that particular agent to perform certain actions. Then another, we have a goal. Goal is nothing but what the end goal we have to achieve and what the purpose of that particular agent it has to perform. And backstory. It's kind of something additional context we are providing to that agent while performing certain actions. And at the end, the tools. So to perform certain actions, agents need some tools. And their tools are nothing but, so on yesterday we have seen the talk from Yash, and he mentioned about to creation of a particular file, and we just need to provide a prompt, and with the help of that particular prompt, that agent is creating a file for us, right? So to create this kind of operations, we need the tools. So these are some kind of tools with the help of that agents are performing their actions. So far so good. So here are some key concepts that we need to understand while dealing with agents. So first one are the agents. As of now, we have covered agent. What are agents? So they are just like LLM, and they have their knowledge base. With the help of that knowledge base, they are performing certain actions. Then second one is task. So task, as of now, the function that used to perform certain actions. And third one is crew. So crew is more important part while we are working with an agent. So you can simply connect this particular term as like your project manager. If suppose we are working in the project and we have team members in the team, and all the team members are coordinated by project manager, right? So likely, crew is the project manager to perform all the tasks from this particular within for the particular task. And flows. Flows are nothing but the connection between all the independent tasks. So we can define the flows like what needs to be done after what. So this kind of the flow diagram, this kind of the flow are nothing but they are giving this orchestration to execute the processes on the agents level. So these are nothing but flow. So talking about in how do we create agents in a Go. So on the screen, here is a simple example by which we can create an agent in a Go. We just need to define a struct with the help of LLM, and along with that, we just need to mention a task and a role for that particular agent. And after this, while successful creation of agent, we need to communicate between, we need to have a communication between agents so that they are going to communicate and perform the task. So here is example where how we can create agents and perform this action. So earlier, I have also explored some frameworks from Python. So as we had heard about LangGraph, Crew AI, and then there are a lot of frameworks are available in the market from the Google and the Microsoft. So one of my favorite is Crew AI, which I've earlier used, and with the help of Go, I can see a lot of the difference in between them. So Go is slightly faster. The result is on your screen. So, but this is nothing. Speed is nothing about. Speed is nothing everything. Let's see some killer features from Go. So Go provides us individual supervision on each and every agent. That in terms of other frameworks, we need to hardly specify that. But in terms of Go, we have an inbuilt mechanism for that, and dynamic agent scaling. We don't need to specify what are the agents, how many agents are going to be work on that particular task. Go itself handling this many counts. And the last one is distributed agent teams. For the communication between their agents, we have an automated agentic teams. They are basically performing the intercommunication between them. So yeah, this is all about the agentic, how we can create agents, how we can assign the task, and how we can perform the certain actions with the help of agentic AI in a Go. So here is my profile. So I'll be making this as an open source, and I'll be working on agentic AI stuff in the future. So I'll be happy if you want to contribute with me. So here is my GitHub handle, and we can connect over the LinkedIn. And thank you so much for your time and listening to me. Thank you so much all.
Thank you so much, Abhishek. So, how many of us love automation and hate the boring task of doing the task recursively? None of us? Many of us. That's great. So, here I welcome our next speaker, Pallavi Sajjan Shetty from Josh Software. She'll be discussing an interesting topic about eliminating manual efforts with automation, but with the zest of HR. Over to you, Pallavi.
So, hello everyone. To begin with, I'll ask a small question. Who all have visited the Josh's booth, which we have set up today? Did you observe we have one quiz app created in-house? Do you know the backend part of the quiz app is created by me? So you might be curious, just created backend, what is the big deal? The big deal is I am from a non-tech background, and when you visit the quiz, there are a lot of verifications that are done, like email verification, have you scanned the QR, filled the form, went to support hawk or not, or internally you just shared the link with each other, shared the screenshot. So everything is checked on the back end So we have created a small workflow on a tool called as N8N. This particular workflow checks 3 steps before you are registered in the quiz. Your score is given. How did I land up on a tool called as N8N? So basically, I work in learning and development department where management related to trainings are pretty much manual. Apart from preparing for the trainings, to be a trainer, we have to stay awake at night, prepare the topic, because we have to cater what 15 to 20 participants who are looking forward to it. But to do that, we have a lot of manual work. Share the feedback forms, share 30, 60, 90 days evaluation to the participants, send the data to their managers. What improvement have been shown in each of the participants in the span of 90 days. And that seems easy, but when you consider we have almost like 50 participants per month. In a quarter, it's 150. Managing that much is a headache. So we came up with a workflow which sends the, emails to the managers, to the participants on its own whenever it crosses the deadline of 30 days, 60 days, 90 days. Along with that, we have also started to give reminder mails. 45 days, this is what we covered in the recent training. Please have a look at it similarly. So let's see how it goes. As you can see, whenever we click on execute, as of now for the demo, I have kept it execute manually. But later you can schedule it on a fixed timer. Every day the mail will shoot at 11 a.m. Every day it will check the date. If today's date is like the date of 30 days for particular training, it will check every day. Now, you must be wondering, is it only for, let's say, sending emails, sending reminders? No. I have also created an AI agent which verifies the document which, suppose you are taking a rent agreement or you are visiting suppose your kid's college where you have to physically submit the documents. On various places, they require you to sign a document. So, I have created an AI agent which can scan the document, and I have given it the prompt that to verify if the document has a physical signature present or not. As you can see, it's downloading the document which is available in the Google form. The verification is done, hence it's going to an email which has approval button available as a form to the recipient. So here's how I have created a small workflow on various of the use cases. So using this, not only I am saving my time, but in this industry where L&D department are growing, I want to grow as a trainer, not as a coordinator. So I can save my time and invest more in preparing for trainings and be a greater training in that. So thank you. Here's my LinkedIn ID. Please connect with me. Sure. Thank you.
All right. Thanks, Pallavi, for solving lot many problems. Our next speaker is someone from pattern, would be discussing something about design patterns. Sorry, I tried rhyming up. Our next speaker is Prasad from pattern, discussing about data engineering at pattern. Over to you, Prasad.
Hello. Hey folks, good afternoon. My name is Prasad Lokpure and I'm working as a senior software engineer at Pattern, and today I would be discussing something around our data engineering landscape at Pattern. Okay. All right, so some points which I would like to cover as part of this talk. So I would be discussing around our own use case, Pattern's own use case. So our previous existing database infra and the issues which we faced, and how this our idea of revamping our data architecture came into inception. And also I would be walking you through our data infra, right? Revamped data infra, so something which we refer to as North Star data lake architecture. All right, so let's consider a scenario wherein we are part of a startup organization, right? So the only thing which you would like your developers to focus on is having a quicker TTM, time to market for your MVPs and quicker iterations, right? You would like to focus them on building your application logic, right? But you don't want them to focus on managing underlying data infra, right? So that is going to eat up all of your time. So obviously, the best solution for this is having a SaaS offering readily available in market. So I think Snowflake is the best option out there, right? And also, Snowflake has good support for relational and semi-relational database, semi-structured database, right? And also, it offers you good support with analytic platforms such as Tableau, right? And the best part is it's a pay-per-use model, right? So if you don't have any heavy workloads, then it's the best thing for you. But where the problems start kicking into the picture. So now you are no more a startup organization, so pat on the back for you. So you are now into a scaled up phase, right? So that's where problems start kicking into the picture. So what would be the problems which we are talking about? So obviously, so your ecosystem has been growing exponentially. Now, instead of having just bunch of services, you are having tons of microservices which are constantly mutating your database. And now your data is not restricted just to structured and semi-structured data, but unstructured data also starts coming into the picture. So while all this stuff is going on, you are as well lacking data lineage and data cataloging solution. So, and yeah, obviously, so because it's a pay-per-use model, so it will eventually start burning holes into your pocket once your big data workloads start growing exponentially, right? So that's where, we started pondering on like what is the best next step that can be taken in. So that's where this North Star data lake architecture came into inception. So let me walk you through that, okay? So starting from left to right, you can see that we are having various sources of data ingestion cycles, right? So you have PII, personally identifiable information, that is user-specific information, that which kind of actor or user is having various authentication, authorization going on into the system. You have your legacy database system, for example, it can be a native PostgreSQL, right? As well as there are stateful data sets being generated by your application code, right? So we are ingesting all of this via Kafka. Kafka is a low latency, high throughput streaming service, which we are utilizing to ingest that into our Apache Iceberg. So Apache Iceberg is right now built on top of our S3 backed data lakehouse. So two questions over here: why Apache Iceberg and why S3 data lakehouse, right? So answer to the first question, Apache Iceberg is nothing but an open source format tables, right? So there are tons of advantages to having Apache Iceberg. So to just name a few, easy and seamless integration with data cataloging solutions as well as compute options. So with this middle part in picture, Iceberg sitting on top of our S3 data lakehouse. So now we have the ability to have seamless integrations with several many compute options. So instead of Snowflake being just one single compute option for us now, Snowflake becomes one of the compute options. So that gave us flexibility to move from a SaaS offering to open source based implementation. So right now we have Spark SQL, DuckDB, Trino, right? So all of these are now being one of all those several many compute options. Yep, so that's how far we are in our journey. So, yep, thanks for being an amazing audience. If you think that the use case was relevant to you, or if we share the same pain, just get in touch with me on LinkedIn and we can discuss more. Yep, thank you.
Everyone would clap or no one would clap? Thank you. So next speaker with us is Gaurav, but the title of the talk is a bit tongue twister for me. Let me take help. Auditable collections for audit data optimization. Over to you, Gaurav.
Hi everyone, I'm Gaurav. I work at Cred in rewards team. So whatever cashback, coins, vouchers you get at Cred, it's our systems which powers those rewarding journeys. Today I'm going to talk about how we optimized the amount of audit data we capture from the request in our hot storages. Cool. Let's answer the first question first. Why do we need to capture audit data? So the primary reasons are debugging, customer support queries, and compliance reasons. For debugging and customer support queries, mostly you might prefer to store this data in some hot storage so that you can have a faster access. For compliance reasons, it's okay that you have this data in cold storages. And let's say, like, if you want to have a non-real-time queries, you can just go and run a data warehouse SQL query to access this data. Cool. Coming back to the storage part, so we have two options. One is the hot storage, like MySQL, Cassandra, DynamoDB, and the second one is the cold storage. S3, you can also store in data warehouses. Cool. Next slide. Cool. So in our case, since I'm part of the rewards team, we get queries like from customers like, why didn't I get this reward? The problem with these queries is that the customer support agent will have to answer these queries in real time within, let's say, seconds to the user. So we don't have an option to store this data in some cold storage database, and we have to store it in some hot storage. So if you see the image which we have, it's like from one system, the cost which we were incurring was around $200 per day. I'll just give you some stats. If you take assumption that you are getting traffic of 500 requests per second and around like 5 KB of data you have to store in the database, and the traffic is around like 10 hours of average traffic, you will end up storing 85 GB of data per day. That ends up to 2.5 terabyte of data per month. And let's say you have a retention period of 2 months, you will have almost like 5 terabyte of data in your hot storage. And as you can see from the image, like this is somewhat for the comparable system where we were obviously having little bit higher traffic than this. So we were like spending around $200 per day. Next slide. Cool. This cost was a bit high for us, and we tried to tackle this problem. So we had like 3 solutions in our mind. First one is to move to a self-hosted database solution. The problem with this approach is that you will have to manage the database. The other approach which you can go ahead with, a hybrid solution where you store the primary key of the record in the hot storage and rest of the record in S3. You'll be able to access this data from this hybrid approach like within seconds. It's not in milliseconds, but still you'll be able to access the data in seconds. The third approach which we had was having a compression strategy. But this has a problem where you have an overhead of compressing and decompressing the data. Cool. So if we take a look at all these solutions, there's a common pattern which we can see. In all these three solutions, we were trying to find a optimal storage for the database. So we were trying to store the data more efficiently. But we didn't answer the fundamental question. Do we actually need to store this much data? And the answer is no. Even though we had like around 5 KB or 5 to 10 KB of data per request, the actual data which we were accessing in the rule engine was around only like 5-10 keys from the entire data set. And 90 to 95% of the data was just redundant data for us. So taking this thing in, this insight into consideration, we built auditable collections, which was a wrapper around Java collections framework, where we were trying to track what all keys got actually accessed within the request processing. Now, how does it work? We overrode the get, contains, and contains all method of the core collections library classes like list, map, and set. And we built something called as like auditable array list, auditable hash set, and auditable hash map. And we also built something called as auditable data aggregator, which the responsibility of this data aggregator was to recursively go and collect all the keys which got accessed in the data. In the data. Next slide. Just a sample implementation. If you see, we have a array list, auditable array list implementation where we are trying to find all those indexes which got used within the request processing. And whenever we get any call to get contains or contains key, we mark that particular key as dirty. Next slide. And in the audit data aggregator, we recursively try to fetch all the keys / indexes which were accessed from that particular collection. Next slide. And if we see the impact, this is like a snippet of how the database traffic got reduced. So we were getting like around 1.4 WCU, 1.4 WCU traffic, and it reduced to around like 85 WCU. Next slide. Talking about the cost, like daily cost was coming at around $200. That reduced to $6 per day. So we had like overall 93% WCU optimization, 98% reduction in our data size, and cost reduction to 97%. Next slide. Thank you.
Numbers don't lie. We live in a world full of assumptions. We assume something is fast because it feels fast. But what if the favorite library of ours is quietly adding milliseconds, memory, and allocations? We assume it's fast and efficient because everybody is using it. But assumptions can lie. Numbers, they don't. They tell us the truth, even if it's uncomfortable. So let's uncover the hidden truth of numbers through benchmarking. What is benchmarking? I know, you know, but still, it's not guessing. It's not about a gut feeling. It's not, I feel it's fast. It's about running the same piece of code multiple times and measuring how much time it takes, how much memory it consumes, and how many allocation it makes. But again, Why benchmarking? Bench, I've been attending these conferences and there have been a lot of questions around benchmarking. And I'm a software engineer at Joe Software, and my previous project included custom query builder in it. And it comes with a lot of complexities. It was difficult to maintain it, it was difficult to understand, it was difficult to upgrade. That's where we wanted to make a decision, should we switch to a different library, but how we can ensure the application performance. That's where benchmarking comes in picture. Benchmarking helps us to compare approaches, catch regressions early, and decide speed or developer experience, convenience. So, with that said, let's see how benchmarking works in Go. Go makes benchmarking ridiculously easy. It's very similar to writing a unit test cases. We just have to use benchmark as a prefix to the function which we want to benchmark and the testing.b type. In that function, we write the piece of code which we want to benchmark. To execute it, we use the first command. It runs the benchmark stat only for one iteration. But remember, benchmark stats vary every time. So we use count flag to run benchmarks multiple times. And also a file name to store the stats of benchmarking. But the magic comes when we put the two contenders into the picture to test it. So we implemented benchmarking on GOM and Query Builder. So let's start with GOM. We use it every day. And for a simple query like showing user by its ID, it took around 1.12 microseconds to 22 microseconds. Memory, 5.3 kilobytes per allocation. Allocations, 60 per operations. Big numbers, right? About the custom query builder, it took around 1.4 microseconds. And bytes, memory bytes, around 312 bytes per operation. Allocation, 8 per operation. Small number, right? Beyond the numbers, GOM brings us the features like migration, relationships, lifecycle hooks, standard error handling, and safety from SQL injections. The custom query builder is faster, but more code, more maintenance, and risk of bugs. But the question is not which is faster. The question is which suits your projects. And benchmarking gives us a clear image that custom query builder is 10x faster, lighter, and leaner, whereas GOM is feature-rich, safer, easier, and more productive for teams. So, with that said, I'll leave you with a note that next time when you pick a library or a piece of function, will you just pick it by your gut feeling, or will you benchmark it? Let's connect and explore more. Thank you.
Another speaker from George Software, Sparsh Arora, would be talking to you about Go performance lessons from TypeScripts. Over to you, Sparsh.
Thank you. Hello, hello, all the people present here for this big crowd. I mean, I have the mic, so I can say it. And I have a clicker now, thank you. Okay, so today I want to talk about some Golang performance lessons that we can learn from TypeScript. Yes, TypeScript recently updated their compiler, and from their native TypeScript used Golang, which improved their performance 10 times. That definitely tells that it has some Golang features that were beneficial to it. Mind you, it was not a rewrite, it was just a port. That means they did not change any logic, but used Golang specific features, and everything was similar for their implementation. Let's see what is there. So concurrency, of course, we cannot move without Go routines. So TypeScript have many files which they need to parse and type check, which can be run independently. In native TypeScript, it was a sequential fashion in which it ran, but in Golang, we can run all these things in a Go routine. So definitely it was beneficial. Uh, Similarly, in our code as well, we should look for situations which are CPU dependent and are IO bound, and they can be run independently. We should separate them out and run in background in a different Go routine. This would help our system to run a bit faster and provide faster response to the user. One thing to note, not spawn Go routines as much as we want. Have a worker pool-like situation so that we do not overflow our resources. Moving ahead with memory efficiency. So Golang defined structs are better than JS objects. So using a typed struct or specifying specific lengths to map definitely helps our memory to provide a predictable allocation in them and have a faster GC collection as well because it knows how much of data is allocated in it. So this always helps our Golang compiler to have a specific amount of memory assigned to it. So using these predefined struct in places of interface is always beneficial if we have an idea about it. So that is one thing we should know about. The next thing would be having batching in our application. So what TypeScript did was, so TypeScript files need to be type checked, which need a setup. Uh, this setup needs a memory allocation and memory allocation. So each file, rather than having a separate setup on their own, would be grouped together and have a single shared context used among them. Similarly, we can have a DB call or even API. Yes, I think now we can have a complete look. So similarly, batching DB calls and APIs would help network latencies, which would indirectly or directly actually have a lesser network or a faster response in our APIs. If we have any event processing, doing them in a batch would always help our system. If your system does not have any issues right now in a sequential event processing right now, but on a scale, it would definitely need one, as requiring to call database at each interval would not be beneficial for our resources and would very easily hog database connection pools. The second thing is startup. Having a leaner startup is what helped TypeScript as well. So they removed not necessary files and only added the required resources in their initialization function. Lazy loading the other resources, that is filling up the cache on demand, is something which would make sure our memory is filling with as much requirement as there is at the moment. And lastly, some predictability using a benchmark-driven optimization, that is pprof. So our compiler has a heuristic way of optimizing our code. It provides inline functions and branching for the conditions that it thinks might occur when running an application. But these are mostly educated guesses, which when using pprof as a tool, we can provide our compiler with specific realistic data that would be used by our compiler and they can use the real-time applications. They can use the real-time requirement that the application is using. If we know what an actual hot function is that needs to be inline, that would be actually useful for our compiler. If we have an actual idea of which condition is mostly targeted, and that could be in our branch prediction, which would help lesser flushing of pipelines and would also have faster execution times. So these are some things that TypeScript used and improved their complete code and had a 10x improvement. We might be using them for sure, but keeping them on top of our head for every time we make an architectural changes or even writing code is always helpful for us. So that would be it, and thank you everyone for listening in.
Thank you so much, Sparsh. We had just one rule, no claps or welcoming our next speaker, Avnil from Jump Cloud. He will be talking to you about quantum computing using qubit. Stage is all yours, Avnil.
Hello, everyone. My name is Avinil, like she mentioned. I am from Jump Cloud. And I'll be talking about quantum computing, which I am exploring since few days now. I just So talking about like in classical computing, we have zeros and ones, like yes. So we have like zeros and ones in our classical computing. So we use transistors inside of the computer. So for storing those, like in the quantum computing, we have qubits. So basically, those are either in state 0, 1, or they can be in both the states at the same time. So until and unless we have, we want to measure it, at that time it collapses to 1 or 0. So there are few concepts such as So now there is so I have my blog in here. So if anybody wants to take a look at that later, then also that's fine, because these slides are not opening currently. So yeah, so basically, so I was talking about qubits, right? So there are few things that, like superposition is there, and decoherence is there, and coherence is there. So these are some few concepts that are used in quantum computing. So it's basically you have qubits which can be created using photons and electromagnetic waves. So those are used like that. And then they can have, like I have mentioned, that it can be either in both the conditions, so 0 and 1. So it can possess multiple states at the same time. So it has lot of capabilities. So, and I am yet exploring these things. So I am quite new to quantum computing as well. So yeah. So a little bit of history of quantum computing we'll talk about. So this quantum revolution began in 1900 when German physicist Max Planck introduced quantum theory. So at that time he described packages were called as quanta. And in 1921 the work further established dual wave particles nature of the light and energy. So and then saw the formal development of quantum mechanics. So quantum mechanics is there, quantum physics is there. So these are quite technologies that are there. So, and the birth of quantum computing theory was in 1950 and 1980. So that is there. And so David Dutch is called as father of quantum computing. So, and Richard Feynman got Nobel Prize in this area. So like I was talking about how the qubits work, right? So those are created using quantum states of subatomic particles like electrons, then photons, neutrons, and protons. So these can be used created using lasers and electromagnetic fields and radio waves. And like I was talking about, so entanglement is also one of the topics in quantum computing. So yeah. So so now talking about how can we actually do those, how can we actually experiment with quantum computing is in the classical computing is we can have things such as quantum katas is there from Microsoft, and then we have Qiskit, quantum Qiskit from IBM, and Google is also working in the field of quantum computing. So there are a lot of new things coming in quantum computing as well. So I'm, like I mentioned, I am exploring those things. So, and if you, either you can have those, quantum computing can be done on classical computing, as I said, but there are a lot of development, like quantum computers are being created. So those are, with the help of normal computing, we can take leverage of qubits and quantum computing. And basically, so, you can learn about these things and explore. And yeah, thank you so much. Thank you for the opportunity as well.
Thank you so much. Do we all remember that we discussed something about trading and we didn't had the PPT ready, but now we do have. Meanwhile, Kamesh was giving some quick advices and tips about trading. So if you guys want to connect with him offline. Before jumping towards his presentation and talk, I would like to do a quick announcement. Any speakers for Flash Talk, please report to backstage. We need to have your setup done. And stage is all yours, Kamesh.
Hi everyone. So today I'll be discussing about building AI agents in Go. So firstly, why building AI agents in Go? I will ask why not. So firstly about me, I work as a senior software engineer in Angel One. I build scalable and trading systems. So I'm a gopher since 2022, and I write blogs in Medium, and I'm an AI enthusiast. We can connect over LinkedIn, and here is the QR code of it. Now coming to the AI agent components. So there are total 4 components of AI agent. One will be the LLM, which you can think of it like a brain. And the next will be your tools, which could be SQL, API, file system, whatever. Now there will be a memory attached to it, which will be the context. So you can think of context like it tracks about your past queries and all. So now there is a reasoning, which is your planner, which decides which tool to call. Now I'll be demoing here a SQL agent, which I've built using Go. So if you see, the architecture would be, the user will be getting a query, and the AI agent has total 3 tools in it. One will be the schema reader, which which can connect to any of the DB, get all the schema details about it. And then one will be a SQL query generator, which is fine-tuned on SQL server specifically. And then there will be a SQL query executor. And boom, you will get the results out. So let me show you a demo. So if you see here, so I have tables like employees and projects. Now, just a minute. So I'll ask my AI agent how many active employees are there, and give me the count document-wise. So if you see the results, so basically first the DB inspector tool, which will be your schema, will be called, and post which the SQL query generator will be called, and then your SQL executor. And you will get results like the number of active employees are engineering 2, finance 1, and something like this. And then let's have one more query where you'll have like what is the project which is currently planned. So if I want to know this, so I'll be entering this query, and so what are the projects that are planned? And again, the same process. It takes the DB inspector tool, SQL query generator tool, and executor. And it will be giving me the data, which is your marketing campaign, Q4. So this is the demo. So now I'll go through how we build it in Go. So now I'll be discussing about a library called TMC LangChain Go. So here, if you see, there is a tool which has been implemented with total 3 functions. One will be your name, and one will be your description of your tool, and the third one is the actual core logic. And if you see the main core of the agent, so we'll be using Gemini LLM here. That will be your brain of your agent. And you are grouping all the available tools. And then you will be having you are actually giving context to your agent, what it can do. So in this case, I have given like, it's an SQL agent and the summary about it. So this is how you will create an agent. And then you can call the SQL agent using a executor call and giving your input, and you get the results back. Yeah, thank you so much. You can scan the QR for this source code. Thank you so much.
Thank you, Kamesh. Next up on stage, we have Punit Singh from Login Radius. He'll be talking about introduction to passkeys and goodbye passwords.
Good afternoon, everyone. My name is Punit Singh. I work in Login Radius. Today, I am here to talk about passkeys. But telling you about passkeys, before that, I want to tell you why passkeys. Passkeys are alternative to passwords. As we all know, passwords are not that good because they are restriction when we are creating a password, or we have to change password every 30 days. It's a bad user experience. Then there are data breaches. In a single data breach, millions of passwords can get leaked. Password theft, and there are many attack techniques on passwords. That's why passkey came into the picture. So what is passkey? Passkey is based on WebAuthn protocol. It's a browser-based API which let user authenticate through public-private key cryptography. So how does this work? When a user go to a website for registration, they generate a private public key pair, and private key gets stored in their laptop, mobile phone, password manager, or they can use hardware keys, and only their email, personal information, and public key gets stored in the website database. So in future, if website get hacked, no credential get leaked. If you want to implement passkey in Golang, you can use Go WebAuthn library. In it, let's assume a person go to a website, they put on their email address, they have to just pass unique identifier into webauthn.begin registration. It will give you the JSON in which you will have domain information, user information, one-time challenge code, and supported algorithms. All passkeys are bind to a domain. If a passkey is created on google.com, it will work only on google.com. So there is no phishing attacks on passkey. When we pass that JSON into navigator.credential.create, a browser API which will run on JavaScript, you will get a pop-up of QR code and bunch of options from which you can create a passkey and send back public key to the server, which we can validate and save through webauthn.createCredential. and that's how registration is done. In the same way, when we want to do login with passkey, we call webauthn.beginLogin with user information. We get a challenge code, and in browser, we call navigator.credential.get. With these simple plain APIs, the flow will start to login, and you will get login. I will show you a quick demo of login. So this is the demo. This demo is created by Login Radius APIs, our CIM platform. We integrated passkey in our login flow. So as you can see, I just put an email and click login with passkey. Now it shows the QR code I was talking about. If anybody of you scan this QR code, it will not work. But if I scan this QR code with my mobile, and there will be face authentication also. It will get login. So this passkey is not only limited to QR code. It works with NFC bands, Bluetooth, and it works on all the browser, all the mobile applications, and you don't have to install any third-party app for it. All this flow is natively inbuilt in all the browsers, and I'm not using any third-party app for QR code scanning. All Android, iOS phones in native camera have passkey capability. So I just want to say that passkey is simple for user, stronger for security, and I believe it is future of authentication. Thank you.
Thank you so much. Next up, we have on stage is Dharmit Shah, and he will be talking about eBPF in 5 hours. No, sorry, in 5 minutes. All up to you.
Hello. Thank you, everyone. Hello. So my talk is going to be about eBPF in 5 minutes. You see hours in the slide because eBPF is a topic which you can't really cover in 5 minutes. It requires 5 hours or even more, but I'm going to try and summarize it in 5 minutes. So what is eBPF? It's actually a standalone term with no real full form, but it's an extended version of, it's an extension of BPF. BPF stands for Berkeley Packet Filter, and it was meant to be technology that was for packet filtering, for your network packet filtering. However, as far as eBPF is concerned, it does a lot more than just packet filtering. It helps you run sandboxed code in the kernel, and in the kernel is the key part over here. As an application developer, you could compile the code and you could run it directly into the kernel, not in the user space. It's got an event-driven architecture, it's event-driven in nature. And as a programmer or as an application developer, you don't really need to change the upstream kernel code or create a kernel module. This is pretty important. We'll go through that in the next slides. Okay, and this is a bit of a mess. Okay, so why do we need it? As a programmer, our Go code or Python code or any code that we write, it usually runs in the user space. That's pretty obvious. However, let's say you are working on something which requires peeking into the kernel. You want to look inside the kernel, but changing the kernel code takes a long time. Even if you are a C programmer who can write patches for the upstream Linux kernel, getting it reviewed and then getting it merged takes a long time, sometimes maybe even a year or more. Other option is you could write a kernel module and you could load it up. However, the problem is if the kernel module goes wrong, something goes wrong, it could panic your kernel, and yeah, then the only option you have is to reset your system. Enter eBPF. That's where you're going to use eBPF. How does it work? eBPF programs are usually written in C or Rust. That's the code that's going to get compiled into bytecode and get injected into the kernel, because kernel accepts only the bytecode as far as eBPF code is concerned. Your Go program is going to inject it into the kernel using the BPF system call, and a verifier that sits in the kernel, it's going to accept that code. But before accepting it, before the kernel accepts it, verifier runs and does a bunch of things. What it does is it's going to check if your code is going to always run to completion. so that it's not going to go into some sort of an infinite loop and not give the control back to the kernel. That's a pretty important thing. You don't want your eBPF code to just run for infinite duration. And it's also going to ensure, the verifier is going to ensure that your code is not going to access some kernel memory. Otherwise, you could really mess up with the system. Once the verifier is happy, the GIT compiler converts your bytecode into the native machine instructions, which means your code is going to run really, really fast, which is not even possible at the user space level. This means you can dynamically program kernel's behavior at the runtime, and you can think of eBPF as a JavaScript for kernel. That's actually how they really talk about eBPF. Next up, events and maps. So as far as eBPF code is concerned, it can be run. I said that it's event-driven in nature, right? So yeah, it can run on predefined hook points. Which are these hook points? They are the system calls, network events, function entry and exit points, which are the K probes. And there are numerous other trace points which have already been existing in the Linux system. If you want to run on something which is different, you could write your own custom hooks. It could be a K probe for something that's happening in the kernel. It could be a U probe for something that's happening in user space program. You can't directly get the data out to the Go map and Go application. This is where the eBPF maps come to the rescue, or they are helpful. eBPF maps are usually in memory, in kernel, sorry, not in memory, they are in kernel key value stores, and that's how your application is going to get the information from eBPF. Yeah, just give me a sec. As far as cloud native use cases are concerned, it's used for observability, networking, and security. I'll mainly cover the networking part, wherein if you are using Kubernetes, you could install the Cilium CNI, and that makes kube proxy unnecessary, and you could even get rid of it. Bypassing host networking stack is really amazing part of it. If you want to learn more about eBPF, there is an eBPF documentary you can go through. There is this talk we did in CNCF Ahmedabad. We did a virtual talk with Bill Mulligan, who is from Cilium. He explained us what it's all about. And yeah, this is where you could learn more. That's it. Thanks a lot.
Thank you so much. Our next speaker is Shramik. But I do not have any description about the topic. I have no clue what he will be talking about. Our next speaker would be taking care about everything. So, welcoming on stage, Shramik.
Hello, everyone. I'm Shramik Gazlekar, and I work for a company called Front Door. I work as a senior security engineer. And what that means for me is I could just say, if somebody asked me a difficult question about my work profile, I could just say it's classified or I'm under an NDA, and I could just get scot-free. Since I'm a security engineer, the lie is very believable. But yeah, I'm not going to keep too much information away from you about what I do. I manage identity and authentication within my company, and there are a few Golang services that I own. It could go in double digits, but again, classified. I'll pick on that one. But yeah, I wanted to share about one of the things that haunts me till date. I've been 7 years in Golang now, and there is one mistake that I made during the very first year of my journey in Golang. I crashed a company's internal systems for more than an hour, multiple hours. And I could give you the name of the company, but I wouldn't. Sony, maybe not Sony, it's classified. And the problem there was I had a recursive read lock. And that recursive read lock was, it is very difficult if you are going through a code review to figure it out. And then it got into a state. And yes, the internal systems were not working. And my manager at that time, he got that bug fixed, but he also protected me at that time from the backlash. And that brings me to this very sad state that I hear from many of the folks that actually reach out to me. They actually want to get away from Indian management. Everybody is complaining that their manager works them a whole lot, doesn't treat them like human beings, and it hasn't been my experience. But like for somebody who doesn't get out of the house much, I would rather have my address stated as a cave somewhere. There are very many people that are reaching out stating that they are having problems with managers, the term being Indian managers. And I kind of didn't like it, but I also thought I'd bring out this message out everywhere out and just ask the managers, the management, the leaders to take this case and treat people with empathy. I know there are very many people out here who has been around the block, have been working in this space for a long, long time, and they might be just thinking what this guy is talking about. It's nuts, right? There are people who are way older. Somebody was talking about the shiny head. Is he around here? Gautam? Sorry. So just saying that, maybe listen to me a bit, try and think about it. Don't just throw out the baby with the bathwater up here, so to speak. And let's think about it just a little bit so that all of us, not just managers, but senior engineers who are taking care of the new people that are coming in, we would treat them with empathy. And I know, like, criticism is an occupational hazard of being in a job, and that's a given. But somebody who is coming in new and is very, very green, they need time to develop that thick skin, and that's where I want everybody, all of us, to just help those guys out till they develop that. And maybe hope that they wouldn't need to use that very thick skin moving forward, but again, the occupational hazards are always there. I'm coming at my time here, but you've been a great audience. And yeah, I'll take my leave now. It's been fun. It's been my quick bit. Cheers.
It was a great talk, Shramik. Next up, we have on stage is Yogeshwari. The topic is AI-powered collaboration. But before that, a final reminder, if we have any speakers in this room, please come to the backstage. Thank you. Over to you, Yogeshwari.
Good evening, everyone. So myself, Yogeshwari from Money Forward India in Chennai. So I'm a senior software engineer, and along with that, I hold a responsibility of AI promotion leader inside the Money Forward India. So moving on to the topic is like today, as I'm working as an AI promotion leader, so we usually do like, explore all the AI features in our SaaS products. So that will help the people to increase their productivity. So that is how like we do pilot programs for each SaaS model AI features, and like Slack AI or like Gemini, Google AI. So we will explore it, and we will like provide the people in our organization to be like leveraging those AI tools to be more productive. So in that case, so the problem we faced is like we faced the challenges of using the LLMs into our product. So whatever, like I can see many questions from the people like that they are more expensive, and data is very massive. So the challenges we face are like it wanted like more computational power as well as like energy for training them. So when it comes to the data, like it needs a vast data, right? So all LLMs are like need more vast data, which is like a web search. So in that case, like privacy is also like very concerned. So in when it comes to the large data set, the latency is also like the performance is very low. So we couldn't predict the like what the decision is taken by the LLMs. So these are the challenges we face while using the LLMs. So what are the solutions we found? Like when we started exploring more about LLMs and wanted to like resolve this problem, we like entered into the SLM. So which is like, what is SLM? So SLM is like a small language model. So this will, how it works is like, it is a compact neural language model that will like concentrate on a particular focused data set that will like with fewer parameters comparing to the LLMs. So that will help you to make a concentrated LLM for like language models for particular task. So that is how the SLM will work, and it is very efficient. So how come this will be like more efficient? So coming on to the like deploy or maintaining it, doesn't need any Wi-Fi connection or internet networks to work. So it is like concentrating on the context where we applied it, like into your application, then the context will be with your application. So that is how the efficiency works out. And the specialization, as it is like specialized in particular task, it will be more efficient than LLMs. And cost is also very less, as we can deploy it in anywhere like edge devices, IoTs, or on premises. So that is the main profit on using the SLMs. So the last main thing is like, it is like privacy and security for your application, because it is used within your application. It is not like using the data outside that your application. So that is the biggest like profit on using the SLM. So here I have given the like differentiation between both SLMs and the LLMs. So here maybe like I have given few SLMs like which is in the market open source that can be integrated with your application, doing for particular task like automating like email generation, or like any document reading and making it into the automation for creating something records. So you can go with this kind of LLMs in the open market. So when you wanted to build a customized one, you can use Google AI Studio. So which is like, you can create prototype on any SLMs, and then there is a code, get code, so where you can get the code. Even I don't know the Python, but I can make it a code with this Google AI Studio, which can be utilized in your application. So you wanted to run in your local, you can make use of Olama to run in your local. So maybe you can explore more about SLMs if you wanted to explore with me. So please connect in LinkedIn with me. So myself, Yogeshwari Mani, it will be available in the LinkedIn. So thank you everyone.
Thank you, Yogeshwari. And with this, we are approaching towards the final talk of the day. Introducing Aditya, who would be speaking about Docker images with Nix. Over to you, Aditya.
So the title of my talk is Reproducible Go Binaries and Images Using Nix. So how many of you all have used Docker? How many of you all have heard of Nix? Okay, so some people at least. So what is Nix? So Nix is basically three things. Nix is a package manager. It's also a language, and it's an OS also, but basically it's a builder, which allows you to build various things like your entire OS. You can build like shells in which you can have just the packages that you want. You can build container images, which is basically the thing that I'm going to talk about. So if you know anything about Nix, you know the language. It's horrible and it's very difficult to learn. But why would you do it? One of the main reasons is it's declarative. So anything that is there, that you have dependencies locked, those dependencies will stay there. So even if you, so one example says like, if you take Docker, Docker will go and actually download the dependencies. So say you have an image that you built today and you have an image that you built 1 month before. So if any case that image, that one of the packages change the Docker image won't be the same. But if you build it through Nix, it will be the same. And the second point is mainly for Python developers. How many of you have been through something called dependency hell? Okay. Nobody else? Or nobody else uses Python? Okay, so when you're using Python, you tend to install packages however, and you tend to end up in dependency hell. But with Nix, that problem is not there because each of the packages is statically linked. Then why would you want to build your images in Nix? Well, whatever that's applicable for binaries is also applicable for packages. And if one of your builds fails in your development environment, it will surely fail in CI. And if it fails in CI, it will also fail in your development environment. And there's some nicer things that Nix does while building packages, which Docker unfortunately doesn't. So how does this look like? Now, this is the way I prefer to write Nix. And as with any Nix person who will tell you, there's like 10 different ways to do it. So in here, I have this module which basically builds a package called gopher demo. So I have this module, I have this package called this in Nix. There's something called derivations. This is one of them, which basically builds a package called Go package called gopher demo. It has some of the arguments, and you can actually, whatever dependencies that you have, you can actually mention it in here, and it will actually go and lock those dependencies. So tomorrow something happens, and if your dependencies change, these as long as you have the same dependency files which are locked, you will have basically the same dependencies. Then this is how you build, this is one of the ways you can build a container image. As you can see, this is basically referencing the same package that I built, Go package that I built over here. And then you can just build it using this command. You build a image using this command, load it into Docker, and run it. That's all. Thank you.
And thank you so much. With this, we have came to the end of this conference. I would like to thank you everyone for calmly listening and motivating our speakers. Thank you so much.